Okay. So our talk today is Modem Madness, Recent Experiments with Dial-Up Modems. So here's what we're going to be covering today. I'm going to start with who we are, what makes us sort of qualified to talk about this stuff. We're going to talk about some previous projects that you may have remembered from our previous presentations and maybe some of the stuff you've seen upstairs that sort of funnels into this. We're going to cover what are modems, what is dial-up. There might be people here who just never experienced that. I'm going to talk about a project that I started called Dial-Up World. We'll talk more about that later. But that then goes into some other modem offerings with different projects we've been working on. Then we'll move over to the state of dial-up today, go through some war stories, some interesting stuff with multi-link, and then round everything off with future efforts. So I'm Mike. I'm a software engineer, but I get much more excited when I get to play with hardware, which in this case does include wiring modems and whatnot together. So I've been doing weird voice over IP stuff for about 13 years. I just love taking all this old analog telephone gear and adapting it to something that is still usable today that people can access. I like to say I role play as a telephone company. So Naveen and I both run Philtel, and we'll talk a little bit more about that later. And then I like to say I notice every manhole cover I walk past. So I'm really big in network infrastructure. I love wandering the city, seeing where all these ancient companies used to run their lines and seeing how those companies have evolved over time. So you'll see a theme of me getting really interested in how big networks interconnect, and I just love that kind of stuff.
All right. Hey, everyone. Naveen here. Also really interested in infrastructure, been interested in computer systems, telephone networks for a long time. Been a phone freak for quite some time now. Something that I've been doing for a while, we talked about it last year, scanning payphones with modems. I've got it all fully automated by this point, so it's kind of running itself, but that's been kind of something I've been massaging over the years. Really big into Asterisk and Dotty and all of that stuff. One of the top contributors to the Asterisk project. Some of you may be using that or have heard of it. Also, try my best to maintain Dotty, although that can be a challenge sometimes, messing with the kernel modules as things change. Also maintain a BBS software package for any fellow BBS sysops out there. Finally, also an environmental activist. I like to focus on kind of the intersection of communications technologies in particular with how that impacts the environment and different groups that may be affected by that.
So previously with us, as I mentioned, we both run Philtel. So that's a telephone collective that aims to install free-to-use payphones in the Philadelphia area. We currently have one running at Iffy Books with a second one planned for Thunderbird Salvage. And on top of running the payphones, we also get involved with a lot of other payphone-related or just general telephony projects. So for example, the talk we did last year, I mentioned how I created the Protel programming line. So this was something that people who had Protel payphones could, just from their payphone itself, dial in a number from the keypad that would connect back to my service and remotely program their phone. So they had something that was a paperweight that you needed all this specialized equipment to get running again. And I just simplified the process and have this service running live. And then Naveen, if you want to talk about NIPCAC.
Yeah, so this is the payphone scanning project. It has evolved a little bit over the years. It's in a slightly different format now than it was last year. But basically, any payphones that we know about out in the wild, typically COCOTs that are operated by PTS, since those are the predominant payphones out there. We try to get usage data from them to understand, how usage is changing over time, what payphones are most frequently used, what are the different usage patterns, and over the years that has yielded a lot of interesting insights.
So we have to start off with what is a modem. So the word modem really just stands for modulator demodulator. And it's a way of converting data from a digital format to a format suitable for analog transmission, such as radio or over the telephone lines. So it's just a big, or in this case, small converter box, essentially. So you can see here they come in many forms. On the left, we have one that's styled in an acoustic coupler. So you would just take the phone handset and place it on the modem. But later ones, like this US Robotics Sportster, it has a direct connection for an RJ11 jack. So I like to say that depending on what era you started connecting to different networks, when you hear the word modem, you might get one of these two pictures in your head. But I'd say most people these days, when they think of old dial-up modems, they're probably thinking about something like that US Robotics box. So next, what is dial-up? So this is really just a method to transmit computer data over the ordinary switch telephone network, which was never designed for data use. It was just for voice, and they found out, hey, we have this whole network, maybe we can make computers talk over it. So dial-up is often associated with internet access, but it's really just a term you can use for any way of having hardware or systems connect to one another over the telephone network. So going back to dial-up internet access, in the 90s, that was the way that you connected to the internet unless you had a lot of money or worked in some big institution or got internet access through your company. It's 75% of households had dial-up internet access in the 90s. So nowadays, that has been surpassed almost entirely by broadband. Not completely, but almost entirely. So you guys probably do not have dial-up, I would assume. Anybody? Anybody still run a dial-up? No? Okay, we'll get more into that later. But yeah, something else I wanted to bring up is that when we're talking about dial-up, especially in this presentation, we're probably going to talk about speeds. So speeds for dial-up access, or technically internet access you have now, are measured in bits per second. So you're probably used to your home internet connection being like 800 megabits per second or 1 to 2 gigabits. This is a lot lower than that. We're talking bits per second. So we're going to talk about some of these speeds and standards and sort of pepper them into the discussion that we're going to have here. But some common ones there, you're going to see the Bell standards, like Bell 101, Bell 103, Bell 212A. And that kind of progresses, but after about 212A, they stopped really using the Bell standards, and we go to the ITU-T standards. So people doing dial-up in the 90s were probably using V34, which is up to 33.6K, and then near the end of the 90s, that's when everything got really crazy with the sort of the Cadillac of internet speeds at the V90, V92, where you could get a full 56K. So dial-up world, which I had mentioned previously. I like to say this is a pretty bad but functioning dial-up ISP that I built in my basement. So I established this in 2021. It was a COVID project, and it's essentially built on trash. So I found this Dell desktop by the side of the road. I took it in, like you should with any good piece of PC hardware you find on the street. And then for years, I had just accumulated these US Robotics modems starting from when I was like a teenager, and I never had any use for them, but I knew one day their use would emerge and I'd be able to sort of form them into something. So the first iteration I did was kind of make it sort of era appropriate-ish. So I installed Server 2003 on that Dell desktop, and I set up a remote access service, or a RAS server, to facilitate the connections that came in. So that I threw completely out of the window. When I moved from my old place to my new place and tried to get that machine back on, it just fell apart. I think the hard drive died. After I played with it a little bit more, the installation that I had on there was just corrupted, and it was always kind of a little bit unstable the whole time I was running it, probably from the age of the hardware. So instead, I opted to do a single board computer. So this is running off of a lay potato right now with Armbian, and that uses mGetty and PPPD to facilitate dial-up connections. So it's all based on this great guide from Doge Microsystems, and they sort of run through how you set something up with mGetty, PPPD on a modern Linux distribution. Their guide is much more focused on like lab use, or something like you're at a convention and you want to set up an exhibit and just have local dial-up access. But I thought, I already set that up on Windows and allowed people to be able to call in. Let me try to do that with this implementation, and I made a couple of tweaks so that I could do the same thing but open it up broadly. So you can call it right now. This dial-up ISP is live at that number. It supports up to 33.6K speeds. We've seen 33.6 handshakes. And this is a limitation for analog to analog communication. So this won't give you the full 56K. We'll talk a little bit about that later. And then it's run with 4 Sportster modems. And there are some Easter eggs there. If you were to just dial that number directly, like with a modem, do like an ATDT command, it'll come up with a list of, I think you can play Zork, there's bridges to different BBSs. So I really like to think of it more as like a Swiss Army knife for, hey, are you trying to get dial-up access, or do you just have a modem built into your old computer and you want to get on a BBS from a phone number? Call this up and you have a couple of options. And another really fun thing is that this is Web TV compatible. So yeah, anybody here remember Web TV? Yeah? Okay. Yeah, so there was an effort that's called Web TV Redialed. So it's a bunch of people, it's like teenagers and people in their 20s who probably never really grew up with this have decided they want to reverse engineer Web TV. And so they built their own back-end server for it. So they got this up and running, and I was like, okay, I can just point some IP addresses in my configuration to their servers. But then it turns out that an old phone freak that I had known probably 20 years ago was also associated with the project, and he was able to acquire the original Web TV toll-free number from the company that has it now. So you can literally take your Web TV that's been in your closet for all these years, dust it off, turn it on. It will call that pre-programmed number that will then call all this crap sitting in my basement and get your Web TV online. Yeah. So yeah, bring it back Web TV. It's fun times. So a question that I get a lot is, how am I connecting all this equipment, all these modems, to the telephone network? I think a lot of people know that POTS lines, so old copper lines going by the wayside, and there's a lot of information or anecdotal stuff where people say, oh, you know, I have the new voice over IP from my ISP or a third-party company. Modems don't work at all. It just doesn't work. And that's not true. So I have these Grandstream HT ATAs. They work really well. I have a VoIP number through VoIP MS. That's just a voice provider that gives you plain switch telephone network access. You could technically use whatever provider you wanted. But these ATAs I have set up that are connected to the modems go back to an asterisk PBX switch I have just running on Debian. And these ATAs act as sort of your analog to digital bridge between the old modems and the SIP protocol. That is what every provider online speaks for facilitating telephone calls. So again, a lot of people say, you have these adapters, how do you get that to work? How do you get that to handshake at 33.6K speeds? A lot of people can get in the, you know, they'll get 9600 or something. They won't go all the way up to 33.6K. But yeah, there's a few little tricks. You can force ULaw, so you have a lossless codec. You do a fixed jitter buffer set to low, and you turn off echo cancellation. Those are what I like to call the 3 golden rules. There's probably other little tweaks you can do depending on your configuration, but that'll get you like 90% of the way there with just off-the-shelf Grandstream ATAs. So after doing this, I've noticed that there's a big sort of revival of people working on dial-up and vintage enterprise networking equipment. So there's different YouTube channels that are really covering this, like the Serial Port. We've collaborated with them on a couple of different things. Collab Retro covers a lot of this stuff. So if you guys are interested in anything from this, there's people out there producing content, you know, as recently as this week on topics like this. But it's really cool to see other people working in this space and be able to work with them and talk with them. And again, I'm not the only one running a dial-up ISP in my basement. So the guys from the Serial Port, they're running one. It's a little more semi-public, so you have to sort of be a member of their project to get into that. But there's offerings from DOS Lab and 2600.network. Same sort of thing. You go to the website, they give you a phone number and connection credentials, and then you can just call up at your leisure. So I got this dial-up world set up, and I'm hooking modems up to the phone network, and I'm thinking, okay, what else can I run? What else has a modem built into it? You start looking at hardware and seeing if it has a telephone jack, and that starts to spark your imagination. So this box you might have seen upstairs if you saw our table. This is the AT&T Scepter. So this is a 1980s video text terminal that supports this beautifully named protocol called NAPLIPS. So North American Presentation Layer Protocol Syntax. And the end of that bullet point there says it was used for 3 years. So essentially, there were these providers in the early 80s that offered access to their own NAPLIPS networks and provided you with one of these terminals. And it was literally like 1983 to 1986, these 4 companies operated, and then they all went bust offering this service. So very, very short window. But this originated from the Canadian Teledon service, which had government backing. And in Canada, these things were super popular. That went on for 10 or 20 years or something. People had these and had access to those networks. So NAPLIPS is essentially a vector format that is used as a GUI. So a lot of like menuing systems in these various services would send over this NAPLIPS binary image that the Scepter would then render in real time. And then it would present itself sort of as like a static image, but usually it would be like a menu with options. So like option 1 has some text, option 2, and then you have a keyboard with this terminal that you would key in your option. So it was really just a lot of that send an image, wait for input, send an image, wait for input. But that basic idea gave you a lot of interactivity. So there was ways to send data back. So you could do online banking, you could do flight booking, weather reports, you could get the latest news. So you got to think that back in the 80s when this came out, if you thought about a terminal, you'd have like a VT100 terminal, monochrome text. This was full color vector graphics back then. So really cutting edge, also really expensive. That's probably why these services didn't last a very long time. There was not a lot of users. So I got one of these terminals, and I mean, I mostly got it just because it looked cool. It was a beige box that said AT&T on it, so I just had to get it. But I ended up writing a Python application that will interface with the modem, and then it'll take these NAPLIPS files, these are still circulating on the internet, made all back in the 80s, and I would just byte by byte send these files over the line to the terminal, and without any more setup than that, the terminal just starts rendering them. So you can see there's a couple pictures here. If you go back upstairs to our table, I have it on a loop. I think there's like 40 files that I found, and it just is continuously sending them. But I wrote this basic server. The code is open source, and if you have one of these terminals, I'm sure you don't, but if anybody does, if anybody's watching this presentation like 5 years from now, I'm sure that number will still be up. I don't turn anything off. You could connect to that number, and your terminal will just start rendering the graphics. So moving on from that, I also recently got this device. So this is a Leech CSD5300 clock system driver. So Leech started making this in 1985, and this essentially supplies timecode for slave clocks and broadcast equipment. Basically, if you're at like a TV station or a radio station and you need really accurate time, this was a rack-mounted appliance that would give you very accurate time. So I learned about this via the Maritime Girl on YouTube. I've known her for years, Florence. She has a great YouTube channel covering all sorts of different pieces of technology. But she put a video out on this, and of course, it has a modem built into it. So I got really excited. The cool thing about these is that they can call other units via 300 baud modem to set the time automatically. So you can have your CSD5300 call any other CSD5300. They'll do their little dance handshake, and it'll set the time of the one that calls in. And what's really cool is that their protocol is set up in such a way that it will determine the latency on the line so that it knows how far away things and how delayed things are, so the time is always accurate on each unit. It takes that delay into account. So aside from Florence, who is running one right now, and me, spoiler alert, The NRC, the National Research Council of Canada, still runs CSD 5300s that you can call into and get the time from. I think they have a bank of like 5 of them somewhere. But something really cool in researching this is that there was a proposed project called the Telephone Time Dissemination Network, where you can see from this diagram over here, they had this whole idea where there would be this bank of master clocks, and then different regions of Canada would have their own clock, which would then disseminate time down to smaller clocks in that region. And we were only able to find a proposal for this. I don't think it actually got implemented. But I really like this sort of utopian idea that Canada had for transmitting time all around the country over telephone line. And just as a note, this is different than NIST's ACTS service that they also still run. So these numbers, as far as I last checked, I think today, I think Sawyer tried calling one and did get some data back. NIST offers this 300 baud service that you can call and you can get the time directly from the government. So like I mentioned, my CSD 5300 is now online. It takes calls at 267-417 time, an appropriate number, yeah. So yes, other than the NRC, the Maritime Girl, and we don't think there's any other publicly accessible CSD 5300s out there. So I'm really hoping more people sort of dig these out of closets or find them on eBay, and then maybe we could start like our own bootleg time dissemination network one day. So next, we go to telecommunication devices for the deaf. So these are electronic devices that allow text communication over the telephone for people with hearing or speech difficulties. So these are also known as teletypewriters, which gets confusing with the other like larger teletypewriters that you might be more familiar with, like the one at the first JawnCon 2 years ago. So this is a much more compact form factor. But they use Baudo code at either 45, 45, or 50 baud, which again is RTTY. And they usually have screens, a printer to have a log of the messages, a full keyboard. They're sort of like little terminals. So being that they're sort of little terminals, I thought, hey, can we use these as little terminals? Could I take one of these to like a payphone, if a payphone didn't already have one installed, put the handset on it, and just call up a computer or somewhere for remote access? Wouldn't that be pretty cool? So I started looking into Baudo-compatible modems, and they do exist, but they're kind of hard to find, they're kind of expensive, and they're not very reliable. So if you look at this picture here, I have 3 of them. Each one has a different issue. It either won't hang up the call, it won't detect a call coming in, it's corrupted. They just don't seem like they were quality products at the time in the 80s when they were manufactured. Now, I only have 3 of them. That's probably more than anybody else has, I would say. I feel like this is a pretty good sample size. But I just wasn't really getting anywhere with them. However, when I was started working on this, I learned that Naveen was also sort of working on something similar.
Yeah, so at the time, I was kind of going through a similar thing where it occurred to me that these are basically compact computer terminals, right? I mean, you have a 24:1 screen instead of 80:24, so you're a little bit more limited. You're using Baudo code instead of ASCII, but can kind of do all of the same basic operations. And one thing that I was looking at is there is a Asterisk module that somebody wrote some time ago, probably 15 years back now, the soft modem application, if anyone has encountered or used that. And so I've been maintaining that in the Freak script tree for a few years now. And in Span DSP, which is the DSP signal processing library that the soft modem and most DSP dependent code really uses, they actually have support for TDDs. So I went ahead and I just used the Span DSP functions to add support for 4545 as well as 50 baud TDD support. And then using that, I was able to point it to the FreakNet BBS. And so that's actually what you see a picture of there, is you just call the BBS and it'll drop you right into the BBS. You can log in. Of course, right now your password can only contain uppercase characters for obvious reasons if you do that, but you can log in as guest. That's fine. And from there, you can do whatever you want on there. You can hop on IRC. Sometimes people on IRC will think you're shouting because, again, you only have uppercase characters. It can get a little bit annoying, but it does work. And in fact, TDDs, for some reason, whenever I travel through airports, I like to check out whatever telephony infrastructure is there. And most airports no longer have payphones, but they do typically have some kind of courtesy phones available. Whether you can make long distance phone calls or whatnot, that can vary place to place. But typically you can at least make toll-free calls. And so I like to test that out. And it's becoming a lot more common for some reason recently for them to also have TDDs in a lot of airports. A few other folks and I have been noticing that. So on the right here, this is a picture that someone sent me of a TDD courtesy phone at the Minneapolis airport. And they have, a few different kinds of models, so they don't all look like this or that. There's a few different types at various airports. And so I'll try to call into the BBS and see how well that works. Sometimes the connection quality is a little bit iffy depending on the carrier that they use, but usually it works pretty well. I mean, it's 45 baud, so it's kind of hard to screw that up. And so if you have a TDD out there, you can go ahead and call that number, and that will take you to the FreakNet BBS as well. And we also have this set up as a demo upstairs. I think it's actually connected right now, where it's connected to IRC, so you can chat with people over this TDD. All right, so shifting gears a little bit and pivoting back to talking about dial-up internet. So Mike already talked about how there's different types of connections. We're going to be talking more about dial-up internet access specifically, as opposed to direct dial connections like to a bulletin board system, for example, which around 1994, 1995, prior to that, people had been establishing these direct connections to specific computers. But as internet access became more available, people instead started calling into ISPs where they could then, access all of these different resources from there instead of having to call different computers individually one by one. So sometimes you hear dial-up internet referred to as 56K access, but I think it's important to remember that this was not really the case for a lot of the time that dial-up internet access was prevalent. In fact, you can see by the chart on the right that speeds, especially in the 90s, were evolving rapidly, right? These new ITU standards that Mike was talking about, the 80s and 90s were a time period of rapid change in terms of speeds, right? You could buy a brand new modem 1 year, and 2 years later it was already obsolete because these new standards had come out and you had much faster speeds that were now available. So, it was a time when BBS sysops were just, going through and replacing their modems every year to try to keep up with the new modem standards. And that finally plateaued at the end of the 90s. We finally got the gold standard of 56K. But you can also see that it was only a couple years later really that dial-up access plateaued, and then ever since then it's kind of been on the decline as broadband access has surpassed it. And so back then 56K was not necessarily a thing that everybody had. And even as dial-up usage has continued to wane, and surely now you would think that that might be the case, but not necessarily. So as dial-up usage has declined, as we were seeing, people often like to ask, are people still using dial-up? Surely they can't be in this day and age, right? But like a lot of older technologies, it's still around here and there. It tends to be pretty common still in areas that are unserved by broadband, especially in a country like the United States, which is geographically pretty large with populations that can be dispersed in a lot of remote areas. There are a lot of areas that simply don't have any broadband infrastructure. There isn't any cable. There isn't any fiber. Most of these areas have, some kind of telephone service. The copper there may not be in the best shape, but it's an infrastructure that already exists that pretty much provides universal access to the internet using dial-up internet in a way that broadband simply cannot do. And so in a lot of areas, that is still what people are using. In fact, I've had some users that I've supported over the years that have been on dial-up internet. One moved somewhere in rural northeastern California where he was far enough away from the town that that was his only option. He tried to get DSL from AT&T, and this was before AT&T completely discontinued ADSL and told everybody to screw off, basically. But even at the time, they were telling him to screw off because even though he wasn't that far from the CO, maybe a couple miles or so, they basically were not interested at all, and so he was just forced to use dial-up. Sometimes it's also voluntarily chosen, often for cost effectiveness or lack of real perceived need to have broadband. So this was actually a few weeks ago. There's a few Usenet news groups that I'm in, and one of them, the conversation of dial-up came up. I think this is when AOL announced recently that they were discontinuing their dial-up access, and somebody said, "Oh yeah, there's somebody on this news group that is still using dial-up," and sure enough, she came in and chimed in and gave her 2 cents and basically said, "Yeah, it's cheaper and I don't really need broadband and it works for me." And that may be true for a lot of people. So it tends to be pretty cost effective, as you can see here. This is just from one particular ISP, but from all the ISPs that I've seen, $10 a month for unlimited dial-up tends to be pretty common now. There are some that charge a lot more, like Panix, I think, has the audacity to charge $29.95. I don't know how they think that's competitive, but $10 a month is usually pretty standard for that. Now, I mentioned AOL discontinuing dial-up, and did anybody here, see any news on that at the time? Okay, so quite a few folks here. And it was kind of interesting for a few reasons. I was a little bit disappointed, though, actually, to be honest, because the majority of the reporting on that kind of event basically came out to, people are still using dial-up, right? Kind of going for a nostalgic angle. But AOL is getting out of the dial-up game, and there's a couple other providers like NetZero and Juno and whatnot. So you still have options. But all in all, I think it was pretty terrible reporting, honestly. People, I don't think anybody did any actual research on what they were doing and what was really going on in the dial-up industry. And I say that because AOL, at least when they were exiting the dial-up market, they did not have their own dial-up infrastructure. And in fact, I don't think they have for some time now. And in fact, virtually no dial-up ISP in the country has their own dial-up infrastructure. They are basically all reselling this one company called Global Pops. Has anyone here heard of them? That's kind of what I thought. So they're all reselling this company that nobody has ever heard of, Global Pops. They're a wholesale dial-up provider. And if you think about it, it kind of makes sense because Global Pops, they basically have local access numbers all over the country, in every single local calling area so that it's a local call for everyone. And in this day and age, with as few dial-up users as there are, it would not really be economically viable for smaller dial-up ISPs to, replicate that, geographically redundant and available infrastructure. So all of these access numbers all over the country, and you can try this. If you go to any dial-up ISP, look up their access numbers, call those access numbers from a terminal. If the number hasn't been disconnected, you'll get a Global Pops prompt. So that's kind of how you can tell. They're all reselling this one carrier. And nobody in any reporting that I saw said anything about this. So the fact is there are still many dial-up ISPs out there, largely smaller operations around the country as well as a few bigger players. But you can buy dial-up access from any of them, and you can use any of the access numbers that Global Pops has. So I've been doing some of my testing with an ISP in California, even though I live on the East Coast, because it really doesn't matter, right? You can log into any access number you want, and it just doesn't matter these days. To my knowledge, apart from a few hobbyist operations like Mike was talking about earlier, there aren't any commercial ISPs in the country that provide their own dial-up access, not going through global POP. So it really is a concentrated industry these days. Also, I was talking to them a few weeks ago. You can get into the dial-up game for as little as about $200 a month for 5-port access. So if you want to become a real commercial nationwide dial-up ISP, it may not be as expensive as you think. All right, so we've been talking about dial-up speeds. I mentioned 56K being kind of this elusive thing, even back in the 90s, where it wasn't around until about 1999 or so. And even then, if you were on a really crummy copper pair with a lot of noise on it, or your ISP didn't support it, or you didn't have the right modem, right, you might not have been able to get 56K. And even these days, it can still be difficult to get 56K, believe it or not. So Mike mentioned there are analog to analog limitations. So obviously, if you are calling an analog modem, and you yourself are using an analog modem most likely, then you're not going to be able to surpass that 33.6 barrier because you need a digital upstream for that. But even if you have that, depending on your type of service, so I actually have a traditional regulated voice service, what Verizon calls POTS over fiber. So it's not Fios digital voice, which is what 99% of people have. I'm one of those oddball customers that only has voice service from them, so that's how I can get this from them. And the quality is very good, but I'm only able to get 33.6 K connections to them. It'll stay up for 8 hours until the ISP kicks me off, basically. But I've tried many times to get higher speed connections, and a few times from the terminal I could handshake at 36K, but never anything over 36K, and I've never been able to get a actual PPP session at more than 33.6. And I've also anecdotally heard this from other users as well, even on copper in urban areas where they were only able to get 33.6. Again, this is all calling into global POPs. So I don't believe it's necessarily a limitation there because as far as we know, in fact, speaking with the guy that does their operations basically, they still have, they're still using TDM for all of this where they have all of these numbers, backhauled into their infrastructure, which itself is V90, V92 capable. So I still need to do a little bit more testing on this, which I can't do myself, but try to, check with other folks in different parts of the country with different types of phone service. But this is all this to say that it is no guarantee that you will necessarily be able to get 56K even today. So it says party like it's 1999, but we actually have to back it up a little bit because 33.6K was what was dominant in 1996. So we've talked about some speed limitations with dial-up. If you can't get 56K, it's really a bummer because 33.6K is basically taking a 40% haircut on your speed, which is already not that impressive to begin with. But something that you can do regardless of your speed is something called multi-link PPP. And this is basically bonding connections together. It's not a concept that is specific to dial-up, but it is kind of interesting in the context of dial-up. So basically, if you have multiple phone lines and you have multiple modems and you have an ISP that supports it, and anecdotally I found that Global POPs supports it no problem. The ISP that I'm using is allowing those connections to pass through. So it seems like their radius server will just authorize any connections, no matter if they're independent connections or concurrent connections in a multi-link connection. So it seems like providers may have potentially gotten a little bit lax over the years, but I think back in the day they would have charged extra for you being able to dial up with additional links, but you might be able to squeak by that now. But assuming your ISP supports it, this is something that you can do, and it's actually very straightforward to do. So these are some screenshots from Windows, but it's really simple there. All you have to do is make sure that multi-link connections are enabled and check all the modems that you want to use. So all of them will show up kind of in a list as soon as you have at least two, and you just check them all, and at least on recent version of Windows like XP4, they'll just all dial out simultaneously and you can dial up. So you can see here I was able to connect at 78.8 kilobits per second. The only thing I found weird about that is using a single modem, I can only dial up at 33.6K. And if you double that, that's only 67.2K. So I'm not sure where the extra 12 kilobits is coming from when I have two sessions up. But maybe one of them was negotiating at V90. I'm not entirely sure about that. All right, so I guess this is story time now. So I talked about this one user that he wanted to get DSL from AT&T. They basically said, screw you, go home. And so, over the years, I've made, various tools and services to kind of help make their lives easier, like text proxies where they put in a URL and just dump out the text from the page. So you don't have to load, all these images and JavaScript and all that crap that they don't really care about anyway. And he was actually pretty happy with that. And in fact, for a number of years, it bypassed the paywall of the New York Times. Because I think if you disable JavaScript, their paywall was ineffective. They've since fixed that. But all that said, it was still very painful for him, right? There's a lot of things that just to function on the internet, accessing basic government websites, things like that, especially during the pandemic. It was very difficult, even with a second phone line just dedicated to data connections. So at the time, I had been kind of experimenting with multi-link myself. This was back in 2021. And so kind of in passing, I said, well, there's this multi-link technology where you could get more than, I think he was able to get 56K, but you could get more than 56K where you are using, bonding basically of these multiple phone lines. And he was actually pretty interested in that. So I coordinated with a few other people to try to get him set up for that. And somehow I actually convinced him to order 6 additional POTS lines from AT&T. I don't know how I did that, but the installer showed up, and you can imagine getting one phone line installed, and he was getting 6. The installer's like, "What the hell are you doing here?" But they got all the lines installed, and it worked. He was able to dial up. You can see these are some actual. I went back through my emails and just kind of excerpted some quotes that he had shared at the time, and he was able to connect and with 7 concurrent sessions get up to about 350 kilobits per second, which at this point it really stops feeling like dial-up and it feels more like really slow DSL. And for him, who had been stuck on 56K for years, it was a huge improvement. He said, it literally feels like high-speed dial-up. This is amazing. Most everything is much more manageable. And this may sound funny, but I guess there's 2 points that I want to make. One is that what constitutes fast in terms of internet speeds is all relative compared to what you've been using, right? 350 kilobits per second may sound slow to most of us, but to somebody that has only been able to get 56K, it can be a real game changer. And second of all, technologies like multi-link, which these days may seem more like, kind of these very interesting quirks almost, can have the, potential to make a big impact on, people's actual lives and their ability to do things. It can actually be really helpful to them. So the unfortunate thing is, unfortunately, this arrangement does not still exist. At some point, he did have to stop doing this. Can anyone guess why? Actually, I'm curious.
Money.
Yeah. So he had eight POTS lines from AT&T. Needless to say, that was not cheap at all. I think it was, I don't know, it was maybe $30 or $40 a line, I'm not sure. And he had long distance as well. So he had a big phone bill at the end of the month, and after several months or so, he was forced to go back to 2 lines. But if cost was not the issue here, right, he would have kept on doing this. And that's, I guess, another point here is a lot of these, limitations that people run into are oftentimes not technology, but they're either financial, as in this case, or in the case of AT&T refusing him to provide DSL, which would have avoided this entirely. That tends to be more business related, right? Like AT&T, we've been seeing a lot in the last few years, has a very explicit anti-copper, anti-TDM agenda. And they just kind of want to burn it to the ground, figuratively speaking. So when you have those kinds of politics in play, it's things like those really that are driving the digital divide. It has nothing to do with technology. It's really mostly, business in those cases. AT&T could have set all of these people up with DSL, but they didn't want to because that would have been, making more use of copper, and they want to make less of use of it. So Mike mentioned the serial port earlier. Some of you may have seen this video that they released recently where they actually did a test of connecting, I think, 13 or 14 lines, something like that. This is something I've been interested in a while to see, how far can you take this, right? He was able to get 350 kilobits per second, and in this test, they got 668 kilobits per second. So this is even faster slow DSL. And they were able to stream a YouTube video over this connection, without any issue, right? There's no buffering or anything. It worked pretty well. So obviously this would be, at least financially unattractive to most consumers, using POTS lines. But it certainly does show that the technology itself can scale. And Mike shared a video with me that somebody had done this with 100 connections between 2 Cisco ASRs recently or something like that. So it doesn't seem like there's any actual limitation to technology itself. It's really, how many modems do you have, and in the case of the PSTN, how much money do you have?
Yeah, so now we can go into future plans. So for me, that is 56K. We've talked about this 56K barrier. And something interesting about this 56K technology is that we're at a point in time where the hardware that service providers would have used to facilitate this is readily available on the secondhand market for pretty cheap, especially compared to its original pricing. So you can see this picture here at the bottom. This is just some gear that I've accumulated to start up this phase of my dial-up world project. So we have an ADTRAN box on the top right there. That essentially will act as a converter between SIP, which I previously mentioned for telephone network access, and a T1 line. So I can get a T1 out. But T1 or TDM, which sort of encompasses T1, E1 connections like that, that's really the key to being able to use digital modems and get that 56K connection. So you can see below that, I have some other pieces of equipment here. There's a Lucent Portmaster 3. So that has, I believe, 20 K56 Flex modems in it. And then that Cisco AS5300, that has 96 digital modems that I think can do V90. It also runs at like 300 watts, so I'm probably not going to be running that full time. But I'm slowly accumulating this hardware. I'll be able to get it up and running at least to do something with.
Yeah, and then something that I'm kind of working on the side as well is, I mentioned that I've supported these users on dial-up in the past, and also that I've been kind of doing my own experiments recently. And basically right now I'm kind of evaluating dial-up as potentially a primary internet connection, which might sound really weird, but it's something that I've been thinking about for a few months now. So I currently have cable where I live, which was $25 a month through Comcast basically, and of course their promotions expire gradually, so now it's gone up to $40 a month, which is honestly not that bad for broadband, right? In a lot of places it can cost more, but it got me thinking. All these internet service providers can pretty much get away with charging a lot for their service in a lot of places because people are dependent. And at the same time, it also occurred to me that a lot of things like email and Usenet, stuff like that, IRC, right? Historically, throughout the dial-up age and even the early years of broadband, most technologies were pretty dial-up friendly. It's only really the web in particular over time, as broadband has become dominant, has gotten very bloated and a lot more hostile, I think, to to users, in terms of JavaScript and just, download sizes. And, this is more, I guess, my opinion, but, I've kind of noticed that the web seems to be getting a lot more useful, year by year. So it was kind of wondering, do I really need to have this all just for web connectivity? Or maybe I could try to get away with less. So this is kind of an experiment in progress to see if I can optimize things in a way that would work well on dial-up, but that's kind of a to be continued story here. So.
Yep, so that's it for us. We're at time, so I don't think we have time for questions right now, but we will be upstairs in the chill out room. If you want to contact us for anything, here's all of our information. Feel free to take a picture, and thank you guys so much for attending.